You can see this. There are four factors we get. These four factors. If you see this result, so which one of this? What is the ratio of three single phase pickup to three phase pickup in the both side of this? What is the ratio?
1.5.
Yeah, 1.5. So which should be there?
Start delta.
Yeah, y dy. So this is not a transformer vector group. It is internal relay compensation. So sometimes vector group may be different, but this compensation may be different in different relay. If you are using the same delta star configuration in one relay, so their compensation may be different from other make relay. So, so it is not required for the this testing manually. But when you are creating characteristic, then manual characteristic, then it is required. Otherwise, in automatic mode, it is already done. I am just verifying and through the this test report so that you can understand that. Otherwise, it is not required. So if there is a different ratio, then if any winding was delta winding, then both the single phase and three phase pickup was same. So in that case, we will select which combination? 1, then y0. Okay. So mostly in delta and star, this will be there. If there is any, suppose star is there, but it never happened, but in case neutral is not grounded, so in that case these two may have in your, so depend on the compensation. Mostly you will find these two cases, and third one is for delta y connection. So this is rarely found, the fourth option. So mostly you will find this. So if I do not know the vector group, but if you uh, test this and you can uh, analyze from result that the both side is a star connection from the ratio. So for a stability test, uh, this is a star-star connection. So it is very easy. It is 180-degree opposite. If it is delta, that has already been explained. It is YD11 or YD1. Depend on that, we have a phase angle for the stability. So this is the stable condition. You can see in the stable condition, differential current will be almost zero. So it is 0.8 ampere, not per unit. And I bias current is, so uh, from where we have found it, you have to see in the measurement. These values in the measurement, it is not measured in test kit. In test kit, uh, these values do not require, because we are following the characteristic. We have already drawn the characteristic, so we are just verifying that point. So actually we are in already injecting I differential I bias based current values. So in that case, we do not need to uh, know this. So, but when we are doing the manual testing, then you have to do this and verify that everything is okay or not. So the transformer rating is it was 150 MVA, I think. So, so based on that, you can convert the this into the primary current also, if you want to mention everything in primary. So, in unstable condition, so you can see the this is I bias current. This is I bias current is same. Differential current is just double because we have changed the kept the both angles same. So it is adding up. So here the slope was 40% and 80%. So as I said, for the first slope, we require 2 point. For second slope, we require 2 point. Sometimes, not sometimes, many of times, first slope go through the origin. So you can have only 1 point also to calculate the slope. So if any case you are not finding at uh, 1 point, then 2 point will always help and provide you the slope percentage. So injecting these values, this is just multiplied 1.5 times. So what is the rated current that is multiplied? The pickup setting in this is I think 1.22 in this case. That is why the slope test values between 1 and 2. So these 2 points we have calculated I differential I bias and I differential I bias. So what we will do, use this formula. By this we have calculated all the points. You have to use this formula in all cases. So we here you can calculate. So you can take any point. Suppose here 202 minus 118. But so that will be the this value, right? So this is around 84. Okay. So similarly, we do for the I bias current 795 minus 590. So it is 205. So if you divide this, then the slope is 40.97%. It is close to 40%. So this way also you can test and find out the slope. Are you able to do this? I think everyone is fed up with only. So it is just a short presentation, not a very long. So with this actual results, you can analyze the slope. That's why I am showing this. So the same formula is applicable for the second slope also. So in this case also, if you will calculate the slope point is, it is 80%. With calculation you have got 79.83%. So which is close to 40%. This is the other way to test the differential relay without template. So now you have learned three ways to test differential relay. Manual mode, you do not require any software, even if local control is there, you can test and the differential relay with this all detail. And the second, if a template is there, just enter the uh, settings of the relay and create template and run the test, which we are going to do now. So suppose we want to test any relay. Suppose ABB relay we will be testing. Here a serial number. So make you have to select, and model you have to select. If it is not there, then you just write it database. So from template, you can select the required model. So this is the characteristic. So, so let us create this and use the same setting for manual creation also. So let me do what is the transformer rating at your place? Just calculate based on that, not the same thing every time. So what is the voltage level I should put? Anyone, whatever transformer you have, just tell me. What is the voltage level of your transformer? Primary, secondary? Anyone?
66.
66. And uh, MVA rating?
75.
75 MVA. So can you calculate the rated current? Sixty-six by 33?
22.
22. So uh, can you calculate the primary and secondary current based on the we learned yesterday? So it is 75 MVA divided by 1.732. If it is a 66 kV side, then we will divide it by 66. Seventy-five MVA, right?
Yes, correct, correct. 656, correct.
75 MVA divided by 1.732. Okay. So and divided by 66. So this is the rated current. So we will put the rated current here. what is the CT ratio? 800 or
800.
yeah, is already there. So the configuration of transformer
Star.
star 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 star. So if any transformer is a star, so definitely this zero sequence current filter should be on. Okay, and now we can calculate the this side rated current. We can multiply this by 3, divide by 66, or it is 22, then we have multiplied. So the rated current is 1968. 1968. Okay. So this is also a star winding. So selected a star, and I believe the vector group also should be 0. It is a star star. Okay. So current rating might be 2000. Okay. So this is the current calculation, and we can take the same setting what we have did yesterday. So point 3 is okay. This was 12, and this one was 1.5. So what was this? 5 or anywhere, whatever. So this is 30% and 80%. So once this is done, then I have to so this you can see. Uh, After this characteristic has been created, uh, this bias formula based on the relay selection, it will be also selected. So in this case, we have to do nothing ourselves. So you can see the CT ratio, what we have put based on that is compensation factor and all these things already calculated. Here also you can see the star star winding was there, and we calculated that single phase to three phase pickup in actual condition. So this was YDY 0. So, so once it is done, we can close this, and so here you can select test point. Okay, all three select. If you run this, so from here we can see how it is testing. So why we do not require I differential I bias current in this case? You can see that we are already selecting these. This is this graph itself is I differential by I bias. That is already calculated. We are taking any point that is based on this ratio. Wherever we are taking, so the ratio is as per this. So like this, if you divide by I differential by I bias, then it should be point three or 30%, then point three it should be. Okay. Or so it is somewhere nearby, so that it start injecting and verify this. So here you can see IA, IB is and I1, I2 is being injected, and when related, that point is recorded here. Okay. So it is in a single phase mode, and if you select the uh, three phase, then it will also be tested the same way. This is the second method through template. If you do not want to use template, then you just need to go there and do not select library. First select the slope, this I bias formula. So here you need to put the setting 0.3. So here the slope calculation 0. So this is being created. If we reduce this I bias current to less than, then the second graph will be visible. So let us reduce it so that so now it is visible. This point is very less. That is why the second slope is not visible when we are selecting them. So whatever point we are getting from calculation, we have done, and it is I unrestrained setting. So we need to check this one is 12 hours. Maybe I can check. So once it is done, you can close it, and the same way. we have created this manually, so we can select different points same way. Only creation is different, testing will be the same way. So we can run the test now. Okay. So this is a three-way you can do the differential testing. Okay. And for harmonic testing, you just we can select the ramp option from here. We need to ramp the current. One side we need to have constant current, other side if we are superimposing or injecting through other winding, as I explained, three methods. So any one of that, the here the setting will be same. So pickup current may be different, depend on if we are injecting through the same winding or other winding, but the option will be the same. So we will change it to the 6 current configuration, because in differential we require 6 current. So maybe we can inject through the second current set, the second harmonic value. So we will write the option number. So we can inject 1 ampere, so it will be easy in calculation in percentage, because second harmonic value is depend on the fundamental current, not the rated current. So even we can inject 2 from primary side, it depends what we want. So 1 will be easy in calculation, so we will put 1, and here balance, and it is if we are injecting in the same winding, then we will keep it in the same phase. If we are injecting through other winding, then we will select the 180-degree angle. Okay, so it depends on testing. So let us keep in the same winding. So we will just have a same angle. Okay, and we need to change it to 100 hertz for the second harmonic testing. Okay, so and we may start the current from 1 or 0.5. If we know the setting is 0.2, then we should start closer to uh, that value, because we just spend more time in testing if we are starting from 1. So if we know the value is 0.3, then 0.2, then let us start from 0.3. And, it is a differential trip at instantaneous. So we keep the time as less as we can. So suppose generally tripping time of the relays are 30 to 50 millisecond, we can keep it a 100 millisecond with some margin. So in delta current, we want to reduce the current, so we can write is in minus 0.001. The you need more accuracy, then you need a little step. this also we will keep 100 millisecond. So it is 0. Our expected current is 0.2 because we are injecting 1. 20% of 1 is 0.2. So if we run this test, then we can get this tripping at this point. Okay. So similarly for fifth harmonic, we can change this to the 250 hertz. So it will test the fifth harmonic blocking. So any question till now?
What is that action? Action.
Action is defined here. So if I will select action at only one phase, then only I1 will increase or decrease based on this. It is just a method. In other software, it will be different. You can select that and it will ramp or ramp down. In manual control, you can just rotate the knob, it will increase or decrease. So this is just this setting. So it is what happening, it is starting from 0.3 ampere and it is reducing is 0.001 step. So when relay will trip, that trip current will be recorded here. So we come to know that what is the second harmonic current till what current it is blocking. So that is what we require. And what is the other test in this? Uh,
This is applicable to the both drawing. You draw the in the board.
Yes. No, not for both drive. It is applicable for the lower one.
Only one winding injection.
Yeah, one winding injection. If you want to do the other winding injection, this will be the same, but this angle will be 180 degree then. Okay. So if you are using the upper method, then it is this way. And the graphical way, as I said, you can also see. Want to use the testing method, graphical way. So harmonic rank test. So here you need to select 6 current sources. Suppose in this case, if we want to superimpose, then we do not require 6 current sources. We can do it from 3 sources itself. So I have enable 3 current harmonic in this IBIC. So here suppose expected harmonic value is 20%. Harmonic order is from where we want to start. We want to start from 30% as we did. Here we need to have a step 0.01. The step. So similarly, if we see the graph, if you want to see the harmonic content, so we can increase this so that you can see in the plot. It was taking other source, that is why it was not running. So if suppose we are starting from 100%, so if see the plot now, if you zoom it, then you can see the second harmonic. So in this case, we do not require to inject two sources from one source itself. You can see the second harmonic is there. So we if we reduce it, then the value will be changed. So it is reducing with this rate. So once we know that it is 20%, then we can start from 30% above that. When we run this again test, then it will not be so much distorted because we have selected 30%, but the harmonic current will be there. You can analyze from here how much percentage is there. So if you move, then it will increase because initially it will be higher because we are starting from 30%. So this way we can see graphically, and if we inject, it will reduce from 30% to gradually, and when the relay will trip, it will stop, and you can find out at exact value relay has tripped. So this is the graphical method you can do using the only three current sources. It do not require six current sources. Similarly, if you want, then you can add the other order harmonics as well. Like if you want fifth harmonic also with this, so let us increase the value so that it is slightly visible. We see a lot. Here you can see it is a mix of third harmonic and fifth harmonic. So the current will be injected with this waveform, and it will whatever way we want to reduce, we can reduce all the harmonic current and see the relay response. So it is only three current which has superimposed values we can inject. So this is the third method of testing the harmonic. So any question till now? So I think this is what I need to explain. Is there anything else? So all other I have already explained. So if you have any question, then ask. Otherwise, we can do the practical session tomorrow, or you have something to do. So it was only differential topic. So I know it is repeated many times. Maybe we can do some more topics next time, not only differential one, so that you can have excitement for learning new things. So all three protections what are there in the presentation, all are almost same type of the protection and same principle. That is why there is nothing more to explain in that. We can do the practical things what we will do tomorrow. Okay. Anything else you want, then we can explain. Any general topic they are interested in, then I can say some more. But if you want, then you can only.
More general